In this video, we'll be reviewing compound probability. So a com compound probability is to determine the likelihood of two independent or dependent events occurring at the same time. So, compound probability uses rules. So it could also be rules to determine the likelihood of independent and dependent events. And events can be classified as independent or dependent depending on what is actually going on in the situation. So let's look at what is an independent event and what is a dependent event. So in an independent event, there are events in which the result of the first event does not affect the result of the second event. So, for example, Susie's selecting 2 chips from a bag of red and blue chips. What makes it independent is we are selecting 1 chip and then we replace it before we make another selection. So, we have a bucket of chips. We reach our hand in, we grab one out, we look at the color, and then before we pick the next one, we put the piece back in. So say there were 10 pieces in there. There are 10 pieces when we pick the second time. So the total pool of chips that are in the bag does not change. So that is independent. Whereas dependent events are events in which the result of the first event does affect the results of the event that follows. So here's that example again. Susie selects 2 chips from a bag of red and blue chips. Now, what makes it dependent, if we were to change the scenario, is selecting 1 chip and keeping before the next selection. So say there's 10 chips in the bag. If Susie takes a chip out and then does not put it back in for the second attempt, there's no longer only 10 chips in the bag. There's only 9. So that changes the total when you have to look at the denominator of the fraction for the second probability. So let's look at some examples of independent events and dependent events. So, dependent events. We talked about it before with keeping it, so that's without replacement. Also, it's dependent if you eat an item and then you have to pick again. So say you're at a friend's house and you're eating breakfast and you're picking from a bowl of fruit, who's going to get what piece of fruit? If your friend picks a banana, there's no longer that banana left in the fruit bowl for you to pick from because they're eating the banana and the banana is not going to be put back. So that goes along with the not putting an item back. Pulling cards from a deck of cards and not replacing them. So maybe you're playing war and you're picking up a card and you lay it down again, it's not going to go back into the deck. Picking out your clothes from your closet to wear. If you pick out a shirt, you can't pick out the same shirt if you already have it on your body. So you're down a shirt in your closet. One person choosing an item and taking it before another person chooses. So say you're at the library and your friend picks a library book, and then you're going to pick a library book right after them in the checkout line. If they found the book first, then you can't also get the same book unless there's more than one. And then the last thing is selecting friends to choose teams. So maybe you're playing dodgeball and you're counting off for teams. If one person gets selected for team A, that same person can't get selected for team B. So they're out of the pool for you to pick from. Now, independent events are events that don't bother each other. So dependent events do bother each other, independent events do not bother each other. So that's when you have something with replacement. I'm picking counters, I'm picking sticks out of a cup, and I put the stick back in the cup, I replace it. Or when you roll a die, the numbers on a die don't disappear. Every single time that you roll the die, all 6 numbers always stay. So that's independent. It doesn't affect. Spinning a spinner. The colors or numbers or whatever you're dealing with on the spinner don't spin away and fly off the spinner whenever the next person spins. Flipping a coin. Sides of the coin cannot disappear after they've been chosen. Putting an item back. So if you are selecting a coin from your pocket and then you're going to put it back in, that's putting the item back. Looking at a playing card and returning it to the deck. So if you're doing like a magic trick and you're pulling one card out and they say return it to the pile, there's still going to be 52 cards in the pile. And then 2 events that are not related. So spinning a spinner and choosing a marble. So if the first event says spin a spinner and then it says choose a blue marble, those 2 events are independent of each other because spinning a spinner has nothing to do with choosing a marble. So if we look at the next page, we're going to determine, are they simple or are they compound independent or compound dependent? So on a shelf, there are 60 novels and 20 poetry books. What is the probability that person A chooses a novel, walks away with it, and then person B walks up shortly after and picks another novel? Now, for this, you need to look at the key words. In this example, person A chooses a novel, and the important part is they walk away with it. Now, simple events is what we learned about last time, and simple events are events that don't have anything to do with that's only one event that's happening. So one thing happens. But in this case, person A walks up and then person B walks up. So there's 2 things that are happening in this case, which automatically bumps it over into compound probability. Now, the question with compound probability is it independent? Do the 2 events have nothing to do with each other? Or are they dependent on each other and they have to work together? In this case, because person A walks away with the book, there's 1 book gone from the bookshelf when person B walks up and grabs the second one. So this is compound dependent probability. Number 2, what is the probability of getting a 7 after rolling a single number cubed numbered 1 through 6? So all I want to do is get a 7 on 1 number cube on 1 roll. In this case, that is simple probability. One thing is happening. Simple. Number 3, the numbers 1 through 20 are placed in a bag without replacing the first number. What is the probability that the first number drawn will be odd and the second will be even? So, automatically, how many things am I doing? I'm doing 2 things. I want to draw an odd, and then I want to draw an even. Because there are 2 things happening, it automatically comes over to compound. Now, I have to determine, is it compound independent? Are they independent of each other? They don't rely on each other? Or are they dependent and rely on each other, and you have to look to see, is it not being put back? Is it being eaten? What's going on? So without replacement right here, that's telling you that it is compound dependent because they are dependent on each other. If I pull a number from the bag, the first number drawn will be odd. Without replacing it, I'm not putting that odd number back. So there's less odd numbers the second time I choose because I didn't put the first one back. And you're always going to assume that the actual steps happen. So I'm going to assume that I draw an odd number. I'm not going to assume that I got some other random number. I'm always going to assume that I got what the problem told me to get, even though we know that doesn't always happen. Okay, number 4. Diamond is playing a game. In the game, she has to spin a spinner that is divided into equal sections of orange, red, purple, and pink. What is the probability that her first spin she will land on pink and then red on her second spin? So, look at how many things are happening. 2 things are happening, which makes it compound. So I'm going to have either independent or dependent. With this, I'm spinning a spinner. If you look back At our previous page, when we talk about spinning a spinner, that is independent probability, because the two events do not rely on each other in order for them to work. Spinning a spinner, the colors or numbers don't just spin off of the spinner after you spin it. I want you to try number 5 and number 6 on your own. Pause the video here and do 5 and 6. A deck of playing cards has 52 cards. What is the probability of pulling a king of diamonds without replacing it and then an ace of spades? Because two things are happening and it says without replacing, this is compound dependent. What is the probability of rolling a 4 on a number cube and pulling a red marble out of a bag that contains 3 red, 2 black, and 5 yellow? Well, there's two things happening, and rolling a cube has nothing to do with grabbing a marble, so they are independent of each other. All right, so let's look at these two examples. In these two examples, they're very wordy, so you need to make sure that you read them. So number 7 says, which of these best describes dependent events? Remember that dependent events rely on each other, and it's either not replaced, or it's eaten, or it's put on, or it's removed from what's going on. So let's look at the choices. Randomly selecting a cube from a bag of 3 red cubes and 2 green cubes that are all the same size, replacing it, and then randomly selecting another cube. The important thing to look for where here is it says replacing it. When it says replacing, automatically that is independent, because it says replacing. I'm not having to remove one from the pile. I can just leave them all there. So letter A is not the answer. Let's look at B. Randomly selecting a cube from a bag of 2 red, 2 green that are all the same size, not replacing it. And then randomly selecting another cube. Because you're not replacing it, that it makes it dependent. So this could be an answer. Now let's look at letter C. Spinning the arrows of 2 spinners, each with 2 equal sections one time. Spinning a spinner is not a dependent, because if you look back at the previous page, spinners actually go into independent probability, because the sides of the spinners don't just go flying off. So this can't be the answer, so that makes B the only answer here. So it took a little bit of wording and decoding, but if you look for the vocabulary, you can see which one is independent and which one is dependent. So I want you to pause, and I want you to try number 8 on your own. So if we look at number 8, it says, which situation describes 2 dependent events? So letter A says Robert has 2 decks of cards. He chooses a card from each deck. Because he has 2 decks, that makes it independent. So that's not the answer. Stacy flips a coin and then flips the second coin. Well, we know that flipping coins is independent. It's in our list. So that's not the answer. John has 2 dice. He rolls the first die, rolls the second die. Dice are independent. That's on our list. Last one. A bag contains 6 red marbles and 5 blue marbles. Jessica selects a marble, lays it on the table, and then she selects a second marble. Because she is laying it on the table and not returning the first marble to the bag, that becomes dependent probability. So D is the answer in this one. Now, let's actually look at how do we solve these kinds of problems. So let's talk about dependent probability first, and then we'll go to independent probability. So we put 2 red counters, 2 white counters in a bag. What is the probability of choosing a red counter, not replacing it? That's important. And then choosing a white. So I'm going to do red, not replace it, and then do white. So the first step is find the probability of the first event. So the probability of red is what we want to draw first. So if we have 2 red counters, 2 red counters, and there are 4 total counters, my probability of choosing red is 2/4. Now, if you would like to simplify that down to 1/2, you can, but I'm not going to, just to show you what would happen. Now, step 2, it says find the probability of the second event, the probability of white on the second draw. Now, I'm going to draw a picture real quick because I think that's going to help visualize a little bit. If I have 2 red, mine are blue, and 2 white, if I choose a red on the first draw and I do not replace it, I had 2 red here. But because I selected red the first time and I didn't put it back in, that red one disappeared. Now I need to find the probability of the second event, which is drawing a white marble. White counter. There are 2 white counters out of 3 total counters that are left. So it says here, remember that we have 2 white counters remaining out of 3 that are left. So I have 2/3 that are white because that first red counter disappeared when we did not put it back into the bag. So this is why knowing the difference between dependent and independent is very important. When you solve probability, you multiply across the top, across the bottom. 2 times 2 is 4. 4 times 3 is 12. And then you can simplify by 4 and you're left with 1/3 probability for that problem. So that's how you would solve it with dependent probability. Now let's do the same problem with independent probability. So let me draw the same picture here. I have 4 counters, 2 red and 2 white. It wants to do the probability of choosing a red followed by a white. And it doesn't say that you're keeping it, so you're going to assume that it's with replacement and you're going to put the red counter back. So it says, step 1, find the probability of the first event. Select red on the first draw. There are 2 reds out of 4 total. So there's 2/4 for our first probability. If you want to simplify 2/4 before you solve, that's fine. But I'm just not going to simplify it and leave it and simplify at the end. Then I put the red counter back into the bag. So there's still 2 red counters here. Then it says find the probability of the second event. Well, the second event is drawing a white marble. Remember that we have 4 counters, 2 red and 2 white, and the probability of choosing a white is 2/4 again, because there's 2 white out of 4 total. Multiply them, I'm left with 4/16, and I can divide by 4 and I get 1/4 probability. All right, so let's do some examples. Ricky takes 2 coins at random from 3 quarters, 5 dimes, and 2 nickels in his pocket. So for number 9, it says, what is the probability of a nickel and then a quarter without replacement? And I like to write down what am I choosing first. So I want a nickel first and then a quarter. And it says without replacement, and that's very important. So we need to figure out how many total coins we're looking at first. So if there's 3 quarters, 5 dimes, and 2 nickels, that makes 10 total coins. Now, what's the probability I choose a nickel? There are 2 nickels, so that's 2/10, times the probability of a quarter. Now, remember, it's without replacement, so my denominator is going to go down by 1 because I did not put the 1 nickel back I chose. I didn't choose 2. I only picked up 1 coin. So I chose a nickel and I took 1 out of the total of my pocket. And then I have to put how many quarters there are. There's 3 quarters. Now, don't drop the quarters. The quarters have to stay 3 because I didn't choose it yet. Now I can multiply. I get to 6/90. And then I can divide by 6, and I'm left with 1/15 as my final answer. Okay. Number 10 it says the probability of a nickel and then a dime. And this time it says with replacement. So when it says with replacement, I know my denominator is going to stay the same because I'm going to put that first nickel back into my pocket. So if it helps you, set up the denominators exactly the same before you get started with anything else. I'm going to put how many nickels there are, and I'm going to start over. I put everything back in my pocket from problem 9. So there's 2 nickels, and then there's 5 dimes. Multiply the probabilities. I have 10 over 100, and if I divide that by 10, I'm left with 1/10 probability. Okay, I want you to try 11 and 12 on your own. Look at the examples that I've given you in 9 and 10. So for number 11, I want a quarter and then a dime, and it says with replacement. So when it says with replacement, my denominator is going to remain the same in my fractions. There are 3 quarters, there are 5 dimes. 3 times 5 is 15, 10 times 10 is 100, divide by 5, and I'm left with 3 out of 20 probability. The next one is a little bit tricky. So it's a nickel and then a nickel, but it's without replacement. So my denominator is going to drop, in this case, by 1. So 10 at first and 9 second, because I kept 1. Now this is where it gets tricky. There's 2 nickels the first time I choose, but then the second time I have to drop it because I picked a nickel the first time. So there's only 1 nickel left in my pocket the second time. So it's 2 out of 90. And if I divide that by 2, I get 1/45 for my answer.